welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Today we have a returning guest. This is the first time you return, actually, Luca Palmieri.
Yes, it's indeed the first time I return talking to you. I think I did an interview with Marco, which was published a few months back. But yes, second time being your guest.
Oh, yeah, this is true. I forgot you have your own series. I was going to mention that. Well, I mean, there's a lot to kind of catch up, right? So I kind of would like to start from maybe just a kind of a quick intro about who you are, and then we can kind of catch up from when we last talked to now. And there's a lot there, I believe, right? You've been quite busy. It's been, what, 2 years, 3 years?
More or less, yes, I would say 2 years. Well, I am a software engineer who's been working in the Rust community for 6 years, more or less, give it or take. I'm probably best known for being the author of Zero to Production in Rust, which is one of the most famous books when it comes to getting started with Rust in backend development. As part of that effort, and more generally, I'm also an open source maintainer, an open source contributor. So I maintain a variety of libraries and tools in the Rust ecosystem. Wiremock, Carcass Chef, various integrations for ActixWeb, and bunch of other smaller stuff here and there, depending on what I need to get done. And yes, last time we spoke, I think I was working either for TrueLayer or AWS. In both cases, I was working on Rust. Right now, instead, I work in Mainmatter as a principal engineering consultant. And I consult. So I do trainings, I partner with teams and clients to get people either to learn Rust or to refine their Rust knowledge and be able to achieve whatever they're trying to achieve. Be it, modernizing an old system, building new systems, trying to improve their existing Rust code bases.
Well, that's a very interesting kind of step, right? So when you're working over at AWS, do you mind talking about what you were doing over there?
No, absolutely not. So at AWS, I was part of a central team that I think was officially named Rust Platform Team, or somewhat along those lines. And what we did specifically was build a backend framework for other AWS teams who were using Rust and needed to expose Rust APIs to either the rest of the company or to the public, so to users of the AWS public cloud. So in a way, that also was a consulting role with a product attached, so which is this web framework. Some people may not necessarily know how AWS works when it comes to microservices. The thing that's somewhat interesting is that they have a custom, well, not custom, but really, they invented their own network protocol schema specification. I'm probably saying it wrong, but basically they have something equivalent to protobuf, where you can define in a schema definition language what the API interface is, like what the operations are, what are the inputs, what are the outputs, what are the possible errors. And then you can generate from this definition schema both a blueprint for the server and as well as clients in multiple languages. That's, for example, how the AWS SDKs are kept up to date. Every single AWS service that's exposed to the public is defined in a SMITI package. And then each of the SDKs in the various languages generates the client from that SMITI package. And that makes it so that all the SDKs are roughly up to date when new versions or new endpoints or new fields are added to those APIs. And so I was working specifically on implementing a server generator from this SMITI interface definition language. And that's quite interesting because historically, AWS only developed servers in Java from SMITI. The only officially supported server generators from SMITI inside of AWS were Java-based. And implementing a Rust-based server generator was quite a step forward for AWS in terms of commitment to Rust. And everything I'm talking about here is, it's not trade secret. You can go find this server generator on GitHub. If you search for SMITI-RS, you'll find the repository. The repository contains the server generator as well as the client generator, which is the AWS Rust SDK, which has recently reached 1.0. So I was in the team basically working shoulder to shoulder with the folks doing the AWS Rust SDK.
Okay, that's interesting. So they brought you on specifically to work on this SDK. Is that the only team that you've ever been on?
Yes, that's the team I've been on. And I was in good company. It was myself, John Jenset, Tim McNamara, and a few other fairly well-known contributors. It was Lucio Franco, Montaigne Stonic. So it was pretty nice squad.
So many of you guys all on one team. I mean, you guys must have been very famous, like an A team or something in particular, right?
I mean, it's nice to work with folks you know. Like, obviously, we had interacted before in the open source ecosystem and collaborated in various ways, and it was very nice to be in one place. This, magic era kind of lasted for 9 to 12 months, and then the team kind of disgregated and everyone went their own different ways outside of AWS mostly.
Was there some event that happened, or?
Yes, Monday did return to the office. That was the event that happened.
Oh, I see. That's quite common, I think, now, since it all happened. I think you were in US for a short time, but obviously, usually, I think you're based out of Italy, right? And now you're back in Italy.
So no, I was in London for 6 years.
Oh, yeah.
So I moved back to Italy last summer. Never been to the US, either as a resident or a visitor, to be fair.
Oh, okay. Is it because of the book that you became underneath the radar of AWS, or was it just your inputs into the community, or so many things at once?
That's impossible to know, I guess. I mean, it was very interesting project. It means you are building tooling that's going to be used in some of the highest scaled services, basically the public internet as of today. So it's unsurprising that I said yes at that point in time. Combined with the team that was already there. I was one of the last ones to join. So I already knew pretty much what I was joining, and it was quite exciting to see those people and be able to work with them on a daily basis. Probably a combination of everything. So yeah, articles, book, talks, general open source contributions.
It must have been pretty exciting to kind of rub shoulders with the people, around you.
Yes.
You must have gotten some interesting input from everybody in the team, right?
Absolutely. And the interesting thing, and this is generally true about open source, not just about this team and, those interactions, is that since everybody keeps contributing to the commons before, during, and after being together in one team, those connections strengthening make it so that you can continue working together even afterwards. And that keeps happening. There's folks I know on the cargo team that helps doing other open source work. All these connections keep being exercised for the benefit, obviously, of the commons in general. And also just, it's nice to work with people you know and trust.
Yeah, I think when you have people who they continue working on this open source project outside of, leaving that job, right, that it really shows how good the project is, or else, they would just stop, because there's so many competing technologies out there. Why stick with this one?
Absolutely. Although, for, clarity's sake, I don't work anymore on this MIDI code generator. I stopped when I left AWS because in the end, that would be like working for AWS for free. Doesn't sound like a smart move.
Also, your heart is in something else, right? But you're still doing some with code generation, which we're going to get to.
Yes.
So I'm guessing that you found the next opportunity and then that allowed you to go back to Italy, right?
Yes and no. I was looking for a remote position anyway, partially because I wanted to go back to Italy. So that was part of the calculation. But I wasn't looking for an in-office job, even if I was in London, to be fair.
Is it Mainmatter, right?
Yes.
They're based in Italy now, or do they have an office in Italy, I think?
They're based in Germany. I think the HQ is legally in Munich, but the company is fully distributed across Europe. So we're roughly 20-something. And I think we cover most European countries from Portugal to Ukraine in terms of time zones. There's a couple of folks in Italy. There's a bunch of people in Germany. There's some folks in the United Kingdom, some people in France, etc.
Mostly European-based, though.
Yes.
So you worked on the generator stuff, and now you're working at this new place. But you're working on this framework, right?
Yes, Pavex.
Where did the name come from?
Naming things is very difficult.
Exactly. That's why I have to ask.
The number one requirement I usually try, to self-impose on myself is to make something that's easy to Google. So that, when you type it into Google, you get more or less what you're looking for. So I was thinking of something along the lines of paving the way, making things easier. Pavex sounded like a modification of that. That was okay, sounded cool, more or less unique. You can find, I think, some floor tiles if you look for Pavex, but it's pretty obvious that's not what you're looking for, so that should make it easier.
For me, I was thinking something about Pavlov in my mind, from the Pav part, but I guess it's not related.
No, not really.
But, it's quite an interesting framework, right? And if you think about your history now, that I have this interesting part about your AWS career, what people mostly know, of course, is the book. Obviously, it's, probably that comes up first when you put out your name. You talk about your web frameworks, how to use one of the first ones. You learned through anger, I guess, how to properly build this kind of things. And then you worked on this generation stuff. And now you're working on Pavex, and they're kind of all related in my mind. I mean, do you see the relation to kind of all these different things?
I think like as you go through your career, everything that you do kind of contributes to your baggage of experiences and a little bit to the toolkit that you reach out for. And I think this goes even, if you look at Pavex and the way Pavex works, this traces even farther back. Like it traces back to me working on C# and using ASP.NET Core, for example. Like there's a lot of what I learned in ASP.NET inside of Pavex. There's also some of the stuff I learned in Python, some of the approaches around testing. Like that's also why I usually suggest people to be polyglots, or in general to be quite open to play around with different technologies, because they enrich your understanding of what's possible and what's desirable. And obviously every single one of these examples had weaknesses or things I didn't like. And so you try to pick and choose the best of everything and try to coalesce it into something that makes sense together, which I guess is also the difficult part and what I'm trying to do currently.
Doing what you're doing is quite an endeavor, right? What was the driving force to get into Pavex too? Because I mean, we could say in general, like, okay, it's just another framework to a certain extent, right? I mean, Rust web frameworks is kind of becoming like a JavaScript front end framework at this point.
Yes.
Sure, not to that extreme, but it's going that way. It's like every maybe 6 months, year, there's another framework out. To me, as an outside person, it's like, all right, different syntax, but same idea, all built on Hyper. Obviously, you can't do too much crazy stuff. But I would say, from my perspective, after digging into Pavex some more, it's definitely different in how you do it, where you have a totally different style and you're using code generation, which, at least the way you're doing the code generation, I don't think I've ever seen anybody else do it. Not to mention, you basically started yak shaving. You created a special code generator just to do the code generation, right?
Yes, I think I definitely strongly trying to win the prize for being the weirdest of the bunch. That's something I'm going for in the space of Rust web frameworks. But I guess the challenge there is to try to contain the weirdness and that complexity to the guts of the framework and try to suck it away as much as possible from the interface that the user uses. I realize we've been talking about Pavex without necessarily explaining what that is. So I'll take like 3 nanoseconds to frame that for folks who reasonably haven't heard about it before. So Pavex is a new Rust web framework, which I have started roughly last year, somewhat seriously. And the idea, the tagline, is that a web framework for professionals. I'm designing Pavex to be the web framework I wanted to have when I was doing 10, 15, 20, 30 Rust APIs when I was working at TrueLayer. In a way, also when I was working at Amazon, there are some ideas and some criticism that I had of the product at the time that I'm trying to resolve with myself into what I'm building now. And it's obviously informed by all those experiences. And as I said, going back, ASP.NET Core, Flask, Django, some of the stuff I did in Python land. And the idea of Pavex is fundamentally to try to speak the language of the domain. And I'll explain better what that means. As you were saying, there's obviously Axiom, there's ActixWeb, there's Poem, there's Rocket, and the list keeps going and going and going. And some of these are fairly unique in their own approach. Warp, for example, is a very peculiar API. There's very little things in Rust that look like Warp, except for Warp. And you may like it or you may not like it, but I think it's an interesting exploration. Like it's an interesting idea taken to its consequences. Rocket as well kind of stands out on its own as having a specific approach to developer experience. And then in my mind, I have everything else. Obviously, Poem, ActixWeb, Axiom, they're different, but they're all very similar. Even if they're not built on the same foundations, right? ActixWeb is not built on Hyper, Axiom is built on Hyper, but fundamentally it's the same architecture. One uses Tower, the other one doesn't. And these things have a material effect on your day-to-day. They change, the libraries you can use, the size of the ecosystem, but they do not really move the needle of what's possible or impossible. And what I want is kind of the best of both worlds. I see on one side the need to get something that does as much static analysis as possible. As a developer, I want to find out before my code gets deployed, even before my code gets tested. I want to find out when I'm compiling if some stuff is wrong. That is one of, obviously, the very nice things of working with Rust. On the other side, I also don't want to get a PhD in type theory to get that done or to interpret the errors that come out when stuff doesn't work. Because the way this usually, is expressed in the Rust universe is you write libraries that try to encode certain properties into the type system. You try basically to use the type system as a proof checker, where you write a proof and make it so that if the proof is not satisfied, then you get an error on the terminal. The problem is that those errors get pretty nasty once the complexity of what you're trying to encode as an invariant increases. And you see this in all the libraries which make use or lean heavily on the type system. You see it in Tower, and therefore you see it in Axiom. You see it in Diesel. All of those things are, it's very nice to get errors at compile time, but not like this. That's usually what goes in my mind. And I consider myself to be a fairly experienced Rust developer. And I myself have sometimes problems trying to troubleshoot some of these type errors. And it's generally not something that I would throw at a beginner. And obviously, it's not like these maintainers are not aware of the issues. Axiom has built the bug handler as a way to try to make things nicer, to try to step in and try to give nicer errors without delegating everything to the compiler. But there's only so much that you can do, because the Rust compiler, as of today, doesn't give you the right hook points to try to do better. And this is something that might change, and that might, change the implementation choices that we do, myself as, the maintainer of Pavex, as well as maintainers of other libraries in the ecosystem. But Pavex starts from the assumption that, the reality that we have today is the reality that we're going to have for the next 5 to 6 years. Like, I don't expect the situation to change dramatically overnight. And so if we want to make web development or backend development in particular in Rust easier today, tomorrow, next year, in 2 years, what can we do? And there's fundamentally two approaches in my mind. You can go down this type-heavy route, as others have done, and in the end, you end up rebuilding something that looks like ActiveWeb and Axiom. And for me, that is not interesting. Like, if you want to go down that route, I fork and contribute PRs. That there's no need for me to start a web framework just to say, I got a web framework. I think that arms the ecosystem. Like, it's much better to concentrate and combine forces on a few choices than to needlessly diverge. The other path is, okay, let's try to do something completely different, and let's see if that brings us to a developer experience, to a level of ergonomics, to a level of correctness that is comparable or better than what's currently available. And that's basically what Pavex is as an experiment. What we do, it's easier to explain when you're sharing a screen, but I'll try to do it in words, is Pavex takes the approach of some of the modern JavaScript frameworks, where the framework itself ships with a compiler. In Pavex, what that means is that you define your API in a declarative fashion. So you say, I have my request handler that goes on this path. This request handler takes a bunch of inputs. You don't have to build the inputs yourself. You just say, every time you need to get a database connection, you can use this function to build it from the database settings. And every time you need the database settings, you can use this function to get them from the configuration. And then the Pavex framework takes this declarative interface. I have this constructor, this constructor, this constructor, request handler, request handler, request handler, middlewares, 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 analyzes it, understands if stuff makes sense, because it might not. Perhaps you have routes that conflict. Perhaps you are missing some constructors. So there are some extractors that cannot be used. If everything is good, then it wires everything together for you. It does what it's commonly known as dependency injection or auto-wiring. And it does that by generating a new crate. That crate combines everything together and gives you one entry point called run. You pass to run usually your configuration, and stuff works. And that's where it goes, where you were saying, right? There is some yak shaving, because you got to write a compiler that takes a description of an API as input and outputs Rust code. That compiler needs to be able to reason about Rust code, needs to be able to understand the function signatures of things, needs to be able to understand lifetimes, needs to be able to understand traits to an extent. There's a lot of complexity in there. But the result, the end goal, is to hide that complexity away. And so what the user sees, since we are the compiler, and we get invoked pretty much like a build script. That's the way the Pavex compiler works. You pass a blueprint into the Pavex CLI. You do that as a code generator step. And then we just generate the crate, and then it's back to normal cargo. But the fact that we interject, that we take over control, allows us to be in control over our messages. So instead of telling you that something doesn't implement, the from request trait, or that something somewhere doesn't implement sender sync, I can tell you, if you're registering a type to be a singleton, this needs to be shareable between threads, because Pavex uses a multi-threaded web framework. It uses a multi-threaded HTTP server, which means that it needs to implement the send trait and the sync trait. And even though the information that's being conveyed, once you reduce it is the same, you got to implement send, sync, and clone, the way that's being delivered, it's in the language of the domain you're operating into. You're trying to build an API. I'm talking to you about APIs. And I'm explaining the requirements, the low-level Rust requirements in the context of what you're trying to do. And my bet, my conviction, having trained tens of developers from other languages to Rust, is that this makes for a much nicer onboarding path than the existing solutions. And the cool thing is also that it allows us to do a bunch of stuff that's just impossible to express with traits, allows us to have interfaces which are very simple. The code has no generics. Most of the user code is just no generics. You just write very boring looking Rust code that a person, at the third day of learning Rust could understand. And yes, there are eldritch terrors inside the Pavex CLI, but it's not your problem. That is my problem. And I think that's what good tools do. They take the complexity away from the user, and that's what the user gets from the tool. I get something simpler and just offload a bunch of work to the maintainer. This is the thesis. Obviously, it's a lot easier, showing code snippets. There's a talk about this that I gave at Rust Lab. The recording is on YouTube. I'm giving a similar talk at Rust Nation. The recording will be on YouTube. So if this sounds a bit fuzzy, you can go check it out. And also there's the documentation on the Pavex website. So you can find it there, and kind of explains and shows what everything I talked about, blueprints, compilation, code generation looks like, and what the errors look like as well.
Yeah, the video you have is quite clear. And going to the documentation, obviously, is quite clear. And we talked this before the show that obviously there's some difference. The video was recorded back in November. Now is almost the end of March. Yeah, but I do like the way it's going. Initially, when I first saw all this code generator, I'm like, oh my God, code generator. Because it always freaks me out because you don't know what it's doing. You don't control it. It could be brittle. But at least it makes sense when you read it. But there was something that I didn't quite get it right. I like to have kind of longer names, not Java-like long names, but, long enough that I can kind of figure out what's going on. You always use this F function.
Yes.
That is just a little bit confusing what it is, but obviously you do explain it, but do you mind to kind of go over that?
Yeah, sure. Let's explain the problem that needs to be solved first and foremost, right? So you are, as I said, you're the user, and you're telling Pavex, I want to have these request handlers, I want to have these constructors, I want to have these error handlers. Now, Pavex needs to do dependency injection. And what dependency injection basically does, in general, not just in Rust, you say, okay, I have this function that needs to be invoked. Let's say it's a request handler for simplicity. The request handler wants to have access to the user ID. Okay, I need to have a way to understand what the inputs of the request handler are. And then for each of those inputs, I need to be able to find the constructors. You end up building a graph of dependencies. That's what every DI container fundamentally does. Now, in other languages, and I'm thinking primarily of C#, which I'm fairly familiar with, you have reflection. So what you can do is you can go ask the runtime, hello, I have a function. Can you give me the inputs? And the runtime can do that because it has reflection. And then you can do this, as a code generator that runs during compilation. You don't actually do a runtime. You can actually do it at runtime. There's various approaches. Rust doesn't have that. There's no Rust runtime where you can go and say, knock, knock, I have a function. Can you tell me the inputs? Doesn't exist. There was long discussion about making some version of this possible at compile time, the whole compile time reflection conversation, which was related to RustConf last year. Don't want to necessarily go into that. But the reality is, as of today, nobody, as far as I'm aware, is actively working on it. And even if they were, that's not going to materialize for N years. Project N to be whatever you want. So either you give up or you're very persistent and stubborn and you find another way to do things. I went down the second path. So what do? Okay, if I have a function name and I'm a human, right? So if I'm reading Rust code and I see some function doing some stuff and I want to know the inputs, what do? I take the function name, I go to docs.rs, write the function name, and I find, the function signature. And that tells me it has input A, B, C, D, returns type, perhaps generics, lifetimes, other stuff. And that's exactly what the Pavex compiler does. So the Pavex compiler takes the fully qualified path or an unambiguous path to something that can be called, be that a function or a method, and then it goes look that up inside the documentation. Obviously, it doesn't go scrape docs.rs as an HTML page. It uses Rustdoc, so the CLI that generates the Rust documentation, and uses the JSON output. So there's a way where you can get Rustdoc to emit machine parsable information. And so you can then parse that information and look for the stuff you care about. I gave a talk about this specifically, just the Rustdoc part, at Eurorust last year. Once again, there's a recording of that. And I think it's very much an underrated tool at the moment in the Rust ecosystem. There's so much cool tools that you can build with that. Cargo and server checks, which was mentioned before, works exactly the same. Like it's built on top of Rustdoc JSON. It's the only way you have today.
I was just going to say that. I'm like, did you talk to him to get this idea, or just happen to be that you guys know each other and both use this?
No. We talked about it. Like Predrag, the maintainer of Cargo Server Checks, he was and still is working on Trustful, which is kind of a super powerful query engine. He was looking for, potential things that could be built with Trustful. I had this idea about server checking. Threw at him as in, it'd be cool if this existed, pretty much at this level, of detail. And he was like, yeah, I think I can build that. And, Cargo Server Checks appeared and then easy iterating on it. So he did all the work. I just, threw a problem at a very capable engineer. But I knew about Rustdoc JSON. Like, I knew about this technology, and it's not by chance that happened. I knew about Rustdoc JSON because while I was at AWS, there's a tool that AWS SDK folks have for controlling which types get exposed inside the API, which foreign types. And that also is built on Rustdoc JSON. And so you can see, as I was saying before, the toolkit you build along the way kind of like gets enriched with everything you do. And so I'm on a mission to preach that more people should be building tools on top of Rustdoc JSON because of how powerful that is. And so you can think of Rustdoc JSON as the poor man compile time reflection for Rust. It can do a lot of things. It has some sharp edges and some stuff that's not possible. But you can go in there with some smarts and say, I'm looking for this function. I want information about it. Now, when you need to look for a function in the docs, you need two pieces of information. You need to know in which crate it's defined, number one, because you need to know for which crate you need to generate the documentation. And you need to know the path relative to the root of that crate. And so that's what the F macro does, fundamentally. The F macro uses the Rust location, I think it's called panic location function or something like that, where it basically tells you where you are in a Rust code base. So it fundamentally gives you some information on the location, which is what we use for diagnostics. So every time, something is wrong with a request handler, Pavex will give you an error in the style of the Rust compiler. Like, the request handler that you register here, and it's going to show the source code with the wiggly lines under the thing that doesn't work. That's part of the F macro work. It's because it tells us where the stuff is. So we can then refine it where necessary. The other thing that it does is super stupid. It takes the path that you passed, so that could be crate : my handler, and just converts it to a string. So it converts it to a string that it's crate : my handler. And then we take that string inside the compiler, then chop it up, interpret it, combine it with the information about the crate it was registered from, and then triangulate everything to find the crate it was defined into, and then find it inside of that crate's documentation. But the cool thing about the F macro is that it's a macro rules macro. So it's not some crazy, proc macro. The definition is 6 lines long. Like if you control click in your IDE, it goes to the macro definition, and you can realize yourself it's actually pretty innocent. And it's very short for the simple fact that you need to write it every single time you're registering something with Pavex. So if this was something along the lines, callable bang, and you have to write that 50 times, get pretty tiresome pretty quickly. So I took the semi-controversial choice of just making it a one-letter macro, which I know a lot of people hate. But I think once you get actually working with the framework, you're very thankful that it's short.
Yeah, that makes sense. I can understand both sides. It is nice to have a short one, but usually we have like IDEs or something like that, IntelliSense that can start to kind of complete it for you, but not everybody works like that, right?
And also, like, generally speaking, just by looking at a piece of source code, if everything is very long, it looks pretty busy. While in reality, the only useful piece of information, it's the argument of the macro, which is basically the path to the handler. And so I want that to pop when you're reading the code, rather than have the visual noise of a very long macro name pretty much everywhere.
Yeah, that's another good point. I totally forgot about that. Having one letter, I mean, it makes a lot more sense. The way you have it set up, it's really interesting, like how you can pretty quickly kind of build up this blueprint, add routes, add arguments, add middleware, add all this stuff. And the testing is pretty straightforward. Like you have this, like that git ping was in your tutorial.
Yes.
I can imagine that one must get generated from like git request to the ping handler, right? Which is pretty clear. Is that right? Is that kind of how the name gets constructed?
Yes and no, not yet. So one thing we're going to do that we don't currently do is generate the OpenAPI schema or some form of strongly typed schema for your API based on the blueprint. And that's one of the advantages of being able to do code generation and being able to do the compile time reflection, that we have a very good understanding of what information you're extracting from the different places and also what information you're sending back. And then once we get the strongly typed schema, we're also going to generate strongly typed clients. And that will help as well with end-to-end testing. And the moment the end-to-end testing is pretty black box, so you spin up the API in the background, and the machine, like the Pavex new project, so something you generated with the Pavex scaffolder, is going to come with some integration tests pre-wired. So all the heavy lifting is done for you, and then you just add routes, basically, as you build your API further. But we are also going to generate that going forward. The framework today is always the worst version of the framework. If when you think in your mind of all the possible things that you could build and all the nice stuff that you want to do, you notice it yourself, right? If you look at what was shown in November and you compare it to the docs today, I think it's nicer, more powerful, more concise. The API looks a bit better. And that was part, obviously, of the process of beta testing it, iterating of what that looks like. But fundamentally, yes, like the idea with Pavex, apart from all the error messages and everything we've seen so far, is to have something that is powerful, as in you have an engine, like you have a dependency injection engine that's pretty capable, but you also got a lot of stuff that's off the shelf. Like the approach we're following in Pavex is the Rocket approach. It's the Django approach. It's the Laravel, the Rails approach. We want to build a framework that has a ton of batteries included. And obviously it takes time to build batteries. If you go now inside the Pavex, you'll find few batteries. But that's because we are focusing on the skeleton and the engine and the core. But the idea is to make those batteries available. And when you start to think about batteries, right, you want cookies, which I built a crate for last week, and they're coming into the framework this week. And then on top of cookies, you want sessions. Sessions need cookies. How do I make sure that when I am installing, for example, a module to do sessions, that the machinery for cookies is available? That is one of the issues I often find when I build APIs with other systems available in Rust. These dependencies are implicit. Like, you try to mount some middleware that does sessions in, let's say, ActixWeb, for example. Cookies are there just because they're first party in ActixWeb. But if you're doing it, for example, in Axum, the cookies might not be there. And then it doesn't work. But you find out at runtime. Because everything moves through these request extensions, like dynamic map. It's not really tracked. Instead, in Pavex, since a dependency injection engine understands the dependencies of all the things, if you try to install something that uses sessions, and those sessions try to, get cookies, at compile time, you get a message that says, to be able to execute, let's throw a name, like the extract session state middleware, you need an input of type request cookies. And there's no request cookies constructor currently registered. And going even forward, which is going to happen, at least for first party, but probably also for third party, is you're going to have an help inside the error message that says, these are the available modules in the ecosystem that define extractors for that type. You may want to bring them in. And this might be something first party, which is going to be the case for cookies. So it's going to be Pavex : cookies. Or it might be something third party. That might be a different mechanism for doing cookies. And that's also due to the way Pavex works and the fact that we try not to use traits too much to provide this flexibility of like swapping the way stuff is created. In a way, we kind of work as a data-driven dependency injection, while traits are behavior-driven, if that makes somewhat sense.
I got a quick question for you. Like, I like that idea that it's like, hey, you're missing this thing. Here's some choices, right? That's really interesting, and I really love that idea. The only thing I can envision about that is like, okay, here's this thing that you're missing. You need to, add this battery. But if you're saying like, okay, here's some third-party choices, how is that going to work for future proofing in terms of like if there's another cookies or even session package, right, that you gave the example of? Is there going to be some kind of central registry that's going to have to ping and say, okay, well, give me some possible solutions? Or is it just, okay, at this time, when this version of Pavex was compiled, these are the ones we knew about, so we're just going to plug these into there? I'm guessing probably the latter, right?
Well, as old systems that you haven't built yet could be various things. The way I think about it, it needs to be curated. Also, because you don't want somebody publishing a bunch of malware on Crates.io that happens to contain a constructor and then, happens to be recommended to your users. That'd be bad. So you want some kind of machine curation, which is you only recommend, crates which have seen a certain level of usage. And then you want some human curation, aka myself, going through those crates and say, okay, you are either a trustworthy maintainer or this crate is trustworthy. So it's going to go into the data bank of the stuff that we think is good to recommend to people. So it could probably work as like a centralized registry where we control what goes into the registry and that gets pinged basically from the Pavex CLI.
Okay, that's interesting.
Fuzzy on the details.
Yeah, well, I mean, this is obviously ideas, right? I'm sure you have ideas, but not quite sure which one you want to go to. But are you looking at having a central managed repository? Because that's also a job in itself, right? Because people are going to be submitting applications if this thing takes off, which I can feel it may, based on the way things that I see. That's quite tricky because now the next question is, you mentioned Rocket, right? Rocket is really quite an endeavor that the one guy took on. I think you're developing this by yourself at the moment, right?
Yes, this is a solo project for now.
So is this going to be, sorry to put this word out there, rocketed in terms of, if something happens and you have to kind of step away, it's just going to stall out for a while now?
Yes, although I think Sergio has gone back to Rocket. Obviously he cut the 0.5 release. He's trying to, I think, increase the buzz factor with the Rocket Foundation effort. So something is moving in that direction as well. But I 100% understand your concern. It's like, this guy is building a framework. It looks cool. Perhaps it's also cool. And perhaps I like it. And I start using it. And then 18 months pass by and this guy's gone. Perhaps he got a new job. Perhaps something happened in his personal life. This core piece of infrastructure that I'm building my company, product, services on, suddenly is unmaintained. What do I do? And I think this is a real risk and perhaps an underestimated risk, which, to be 100%, brutal, affects all Rust frameworks, all the major ones. ActiveWeb is primarily maintained by Rob. If Rob disappears, I don't want to say that development stops, but it probably stops for a while and it'll take a long time to resume. Axum is pretty much the same. There's 1/2 people maintaining Axum. Yes, it's part of the Tokyo project, but look at the commit history. If those 2 people leave, or one of those people leaves, the project stops. And we've seen this in other Tokyo projects as well. Tracing as the same. It's a Tokyo project, but in reality, is maintained by 2 people. 2 people that at the moment actually are busy with something else, which is perfectly fair. And the tracing project is pretty still. And this is an issue which is not Rust specific. This is an issue of any kind of open source project. And if you broaden your view beyond Rust, you can see this happening at various rates, at various points in time in all the other ecosystems. JavaScript, Elixir, it's common. And I think you need to choose your poison in a way. Like if you're a company and you are starting to depend on a piece of software, and that piece of software is open source and maintained by volunteers, you need to factor in the risk that those volunteers may go away and you become the maintainer. Not necessarily of the upstream, but of a fork of that piece of software, which I can trust you has happened to me in Rust more than once in the past 5 to 6 years, because the ecosystem is young, what's cool today is not necessarily cool tomorrow, and suddenly you have more and more software that you kind of like grandfathering in because you used it, and you need to keep using it because it's useful, but the upstream is pseudo gone. And there are two scenarios, right, to make an open source project maintainable. Number one, somebody's making money out of it. Number two, you hope they're going to have free time forever in the future. Now, I don't believe in number two. Like, eventually, projects, especially the ones that have few maintainers, die. Especially if they're projects that require very active and continuous maintenance, such as a web framework. Like a web framework that's batteries included is never done. Because what is considered, cool and new today is going to be table stakes tomorrow. Like, you need to keep working on it. Which is why stuff like Laravel and Rails is, more than a decade old? I think Rails might be touching on 2 decades. I don't know the exact dates. But, at no point they stop and say, okay, Rails is done. Like, nothing to see here. Just keep using this piece of software for the next 20 years. They keep working on it because the ecosystem changes. And so you need to have a way as a maintainer to fund your work on the framework. And there's a very, very, very nice and somewhat cynical talk from the creator of Elm. For those who don't know, Elm is a functional language that transpiles to JavaScript, which for a period of time was pretty cool in the front-end community as a way to build front-ends that was, maintainable, nice, somewhat batteries included. And then Elm kind of died. The maintainer stepped away, more or less, stopped being updated, and the project kind of fizzled out. And he gave a talk, I think it was Strangeloop, the name of the conference, but he gave a talk about the way he was thinking about Elm, the way he was thinking about the sustainability of Elm. And he identifies, the usual business models for open source. You get a Patreon, where a Patreon is either donations from people or donations from companies. So you may get hired, for example, at a big company to work on your open source project. That's something that Guido von Rossum in Python has done several times. That is something that's happening in the Rust ecosystem. A lot of Tokyo maintainers are paid by AWS. A lot of Rust project maintainers are paid by AWS, Microsoft, Google. And so they make sure that those people get a salary, and their main effort is working on the project. The downside of that is that the project may cease to be pivotal to that sponsor over time. Or working primarily in open source can make it difficult for you as an employee of that company to actually advance in your career. There's a lot of talks about this in the Kubernetes ecosystem that has gone through the motions of this for the past decade. So it's a model that can work, but from the maintainer's point of view, it's pretty fragile. You're a little bit at the whim of the wind. And if the season is not the best season, like for example, last year and a half, when tech kind of went through a little bit of a mini recession, the first thing that dries up is sponsorships, which is not nice. The alternative is try to build a consulting business where you have a complex piece of software that is open source, and then you also have a consulting company, and the consulting company helps people use the open source software. These happened for many years, for example, in the C# ecosystem, where Identity Server, the main OAuth 2 or OAuth implementations for C#, was fully open source, and the maintainers operated a consulting company that helped people, configure, work, maintain Identity Server deployments. The thing that's not so nice about this model is that you're incentivized to make it so that the software is not very easy to use in the long run, because you want people to give you money. And if the software really works and it's easy to use, they don't need anybody to help them. So there's that. Then you have open core. So you say, I got this piece of software. You can do some stuff for free. I can do more stuff if you pay me. And that also has its failure modes, because then you are incentivized to kneecap the open source free version, because you want people to convert to the paid version. And we're going through the motions of these again with HashiCorp, Vault, and a bunch of other projects in pretty recent memory, like past 1 to 5 years. And I've been around the block for a few years. I've seen these things play out, and I was like, I don't want to do any of this. But I also want to build this project, and I also want to have time to work on it. So what do we do? And to finally go back to your question, the answer for me was, Pavex is going to be open source, but it's not going to be free. So Pavex is going to be a commercial project. This commercial project will require you to pay some kind of monthly subscription. It's going to have a generous free tier for individual usage. So you'll be able to work on your solo side projects for free. That's perfectly fine. But if you want support, so be able to open issues and get them troubleshooted. If you want high-level support, so being able to call someone at 2 a.m. in the night saying, my 20,000 Pavex deployments are having issues. If you want to use this commercially in a bigger team, you'll be nudged towards paying for it. Now, obviously, I also said that Pavex is open source, and I've also said that Pavex is not open core. So to an extent, this is a gentleman's agreement. Like at any point in time, you can fork the code base and use it for free because the code is free. The source code is free. But the product, which is the code, plus the maintainers, and everything that goes around it, cannot be free. Because the maintainer's time is not infinite and also not free. We need to pay rent, we need to pay food, and generally, we deserve something that makes comparable salaries to what we could get if we abandoned our passion projects and went to work primarily commercial. Once again, this makes me the weirdest of the bunch. When you go out and you say, we're making a web framework, and you're going to have to pay for it. People are like, oof, why would people do that? And this is going to be a speed bump, but fundamentally I don't care. I think it's good to come to terms that for things to work, they need to be sustainable. If you want to build a core piece of infrastructure, such as a web framework, and go to a company, big or small, doesn't matter, saying you should build on top of these foundations, the responsible thing to do is to make sure that those foundations have a mechanism to be sustainable, have a mechanism to make sure that, 2 years and a half, 3 years from now, this framework is going to be maintained because you are paying some money together with all the other people that are using it commercially. That money allows us to pay probably part of my time as well as other people that are going to be doing support, that are going to be doing features, that are going to be doing bug fixes. And it aligns incentives. You are paying for the product. And so we are incentivized to make the product better. You're not paying for help to use a free product because the product is complicated. You're not paying for a cloud version, which incentivizes us, to push you towards the cloud version so that we get some money. You're paying exactly for what you're getting, which creates a very nice flywheel. The more people use it, the more money we can invest into it, the better it gets. And this is going to have also some ecosystem effects because obviously once we have a pot of money, you can also incentivize others to do that work. If you're building third-party stuff on top of Pavex, that makes it easier to use Pavex in certain circumstances, then we have some money to fund that as well. So, you can distribute some of those funds and make it so that the ecosystem around that framework is also sustainable. But there needs to be an entry point where money comes in. Otherwise, it's just volunteers on top of volunteers on top of volunteers on top of volunteers. You're just waiting for some of those chain links to break. And they eventually do, pretty much mathematically. I think if we have learned something from the past 15 years of open source or corporate MIT, very permissively licensed open source, it's that.
That's a good point about the licensing, right? What license are you looking to have for this?
Oh, it's an Apache 2 license.
Okay.
So as I said, the code is permissively licensed. It's free. You can fork the source code, use it for free forever. I don't want to make, the usual, we're going to use a closed source license, but send us an email. And for some money, we'll give you something that you can use. I think you need to make this kind of stuff open source. Also because making it open source is by itself de-risking for a user, right? If Pavex, the commercial entity, for whatever reason, goes belly up, goes in a direction you don't like, you can always say, okay, I'm going to fork, and I'm going to take this project my own direction. So that's why we want to keep it open source, because it helps others to contribute and it also helps others to use it. We want to make it sustainable. It's not necessarily that we want to build the next $1 billion company. We want to build something that makes it so that work is being paid at the rate it's worth, and the whole machine kind of works as it should forward.
I like the idea, and I can understand as somebody who's a business owner, somebody who has to pay bills, you need to have a revenue source. So it is tricky. You have to make this kind of choice. So I don't look down on this at all. In fact, I think it's the right thing to do, right? To be responsible, sometimes you have to make those choices that people may not like. But I think that if they step back and think about it, Yeah, something needs to happen. And like you said, there's so many people that says, okay, then get on our cloud. But what's the percentage of people actually do that? Especially the audience, right?
Yes. And then in the end, right, as all somewhat commercial projects, they may or may not work out. If we find out that there's not enough interest to motivate people to use Pavex and pay for it if they're doing like a business project, and you think, I'm going to stick to the open source framework and free frameworks and take the risk that they're going to go out of business and take the risk that there's nobody I can escalate to, it's fine. It means that we have established that the product was not good enough to warrant whatever price we choose to put on it. And as all good companies that fail, we go out of business and we shut it down. It's okay. Like, I think you need to embrace the possibility of failure. Obviously it's not the one you're shooting for, but it needs to be on the agenda. Like, it's okay to try and it's okay to fail. We'll see.
Now, you keep saying we. As of right now, it's just yourself, right? Or do you have some other people working with you?
Well, that's the Italian royal we. I don't know if you said it in English. When you're speaking on behalf of a project, you use we as a collective. Obviously, ambition is to be more than I. There's some people starting to contribute. I'm sure there's going to be others. Obviously, the project being in a closed beta doesn't help with getting a tons of contributors, but that was by design. Like, I didn't want contributors at an early stage in the project, because when you are in an early stage, the code moves very quickly and there's not necessarily the final form. And, I'm merging PRs which are pretty large. And then, you're trying to do a contribution and then you're full of merge conflicts. It's not nice. Like, I want to get contributors on where you are at a point that there's good issues for them, to work on. There's bandwidth to actually mentor them. And it's pleasant, right? I want to spare them the I'm rewriting the internals once every 2 months phase, which thank God is finished in the past couple of months, but it was pretty much the case for several months, which is good. That's what you want to do. You don't want to crystallize something that doesn't work, but that comes at the expense that you can't get as much help from outside.
I did want to touch on the beta process. We were talking before we started recording. You mentioned about why you did this closed beta, right? Do you mind to kind of go into it, the positives, even sometimes the negatives of this closed beta?
Absolutely, which was another thing that I think got a bunch of eyebrows raised. It's like, you're doing an open source project and you're doing a closed beta. Why is that? I have learned over the years that it's faster to iterate if you have a few users who are actively trying a product. And it lowers the cost for pretty much everybody involved. If I go out there on Pavex 0.1.2 and I say, go use the framework, a bunch of people are going to give it a try all at once, assuming, I've managed to make a big splash with the announcement. And the framework is definitely not at its finest, right? Because it's the first release that people get to use. So there's going to be a bunch of bugs. There's going to be a bunch of subpar APIs. There's going to be just blind corners that I haven't thought about. The folks are going to find because they don't have, the mental understanding of how the stuff works inside. So they may try to push the tool outside of what has been tested. And this definitely happened. But if you get all your potential users to give a try to the first version, and then it's not necessarily good enough, it's very difficult to get them to try it again. That takes a lot of energy to reactivate those people. If you do a closed beta, instead, you build a pipeline of people who are interested in the framework. And what you can do is you can give them access in a staggered fashion. Usually I do like 10, 30 people every 2 weeks, every month. You get them access, they start with fresh eyes, and they see the framework at that point in time. They try to do a bunch of stuff, and they report issues and feedback. Error handling is too verbose. These method names are very annoying. I got a panic trying to do this. And I fix it. And then I get a bunch of people who haven't seen the issues before, try it again. And every time I'm getting new stuff, because it's not like, they're retrying the same stuff over and over again. They're always looking at the best version. And I'm trying this process as a way to iterate to something that when it goes out in public, it's not going to be a 1.0, but it's sure going to be a 0.2.0 that's a lot more baked, to the point that I think it can stay pretty stable API-wise for several months, instead of having to go 0.1 and 0.2 and 0.3 and 0.4. And then people start to build extensions, and then the extensions have churn because the framework is churning. And that there's a lot of second order disruption due to the fact that you're building on something that's very unstable. I want to go out with something that's fairly stable, to the point that I think I can, maintain it for a year, whatever that is. And the close beta process helps. Obviously, it comes with cons. That means that you're getting a lot less users because you are intentionally stopping them from using the framework. I mean, some people get frustrated because they're like, I want to use this thing and I can't get access. That is annoying. It also means you're not getting as many contributors as we were touching upon before. It also means you're not getting third-party crates deployed to Crates.io. So your framework stays smaller. But the bet is that that's going to pay off when you go out. It's nicer, more battle-tested, more baked. People are just going to have a nicer experience using it. And, part of it also ties into all the stuff that we were talking about around the commercial aspect of things. If you are going out there saying, we're going to do this and we think you should give us some money for it, you need to have something that's good enough. Like, you can't go out there with something that's half broken and say, you need to pay me because, why not? I would say, why should I pay you? This is not good. So that there's a bar of quality that obviously is self-imposed. It's what would I pay for? Type of bar of quality. But I don't want to go out with an MVP in the, Silicon Valley MVP style. It's like, it's broken if you touch it in the wrong way. I want to go out with something that is small, right? It's the first iteration of something that has big dreams. But that first iteration is self-consistent and works well. And then we're going to grow it. But we're growing it from a base that's solid. So that was the rationale.
What do you think is going to be like a 1.0 version? I don't know much about ASP Core, but I'm guessing that must be huge because it's Microsoft, tons of money pumping into it. Rails itself, if you look at it now, because I'm pretty familiar with it, I did a lot of Rails a long time ago. Sometimes I peek on what's going on because they do have a lot of influence to other communities. They have a lot of stuff that's there, right? This active support, active record. You did mention Elixir. They did this whole live view thing, which you've probably heard of, where it's like rendering on the server side. That pushed a lot of people to look into that. I mean, if you look at a framework nowadays, it's not just batteries, but bells and whistles and everything else, right? There's a lot of stuff to go in there. So what would be like, I guess we don't have to say it's an actual 1.0, but like an actual open, production ready, start building with it. This is going to be the base. Like, what kinds of modules are you looking at? Obviously, like you said, you're going to have sessions, which in turn means you have to have cookies or something at least similar, right? Because it looks like you're saying this is focused more towards APIs. But don't forget, we still have a lot of people who are actually still building server rendered applications and monoliths and things like that. I'm still kind of curious, in your mind, what is the base set of modules where it's like, okay, this is kind of like our base. This is where we're ready to say we can start working with it.
So, as you said, backend means so many different things, right? Like, backend means a server, backend means a serverless function, backend means an API that's backing a website with server-side rendering. And if you try to be state-of-the-art in all these categories at once, you're never done. And it's fine to be never done, but that cannot be the milestone you set for yourself to say, we're going to go out with a 1.0. So the objective is to have something that it's solid enough to do a macro service in REST. So it has all the primitives required to build something complex, to build something that 5, 6, 10 developers would work on, and for them to be able to do so productively, to be able to build, for example, an API, not necessarily does server rendering, but it takes care of authentication, that takes care of cookie management, that perhaps has some level of background tasks, there's some facilities for doing some level of caching, can support TLS. There's a bunch of things. Now, at the same time, we're not competing with Rails, right? From the get-go. We're competing with what's available in REST right now. And the reality of that is there's nothing even close to Rails. So from my point of view, once we have the bells and whistles that are available in the other REST frameworks, I think that's a good point to say, this is ready for prime time. And then you set your eyes on the Rails and the Laravel, and you slowly close the gap. And that also depends on which people come and use the framework. Because obviously, if there's a wave of people doing server-side rendered, front ends with a REST backend, okay, now we're going to look more into templating languages. We're going to look more into all the things that requires. But then if, as I suspect to an extent, the interest is more on, microservices, serverless functions, everything that's in that domain, then you're going to go deeper into there. Perhaps you look into gRPC support as a higher priority issue. You look into, as I was saying, OpenAPI schema generation, all the things that are usually more interesting if you are either offering an API as a service or you are an API in a microservice architecture that needs to talk to other stuff. Perhaps you look into, queue systems. There's a lot of directions you can go into. And I think it's good to plan to an extent. I think you also need to go with the flow. Like see, who is interested into using this and kind of double down. But once we got something that is more or less on par with the existing Rust offering, I think that's a good point to plant a stick in the sand and say, we exist. Use this.
No, that's a good point. I totally forgot about that. Like, as long as you're up to par with what's around you, that's a good point to say, okay, this is good. And like you said, I do agree that the landscape in Rust is still quite low in terms of features. It's a great point. And that's not necessarily a bad thing. I mean, Rust is used for so many different things. It's not like Ruby. If you do Ruby, it's most likely you do Rails. Do PHP, you're most likely doing websites. I mean, it's PHP, right? It's basically a web language. Same with JavaScript. That's not the only thing they do, but at minimum 90%, right? For these different languages. Rust, I mean, that's super open. You could be doing so many different things with it. So I can see that might be why the web side of Rust is much less mature, right?
I mean, there's so many different explanations we can give ourselves as to why the website of Rust is not necessarily as mature. Part of it might be that, if you don't have the stuff with the bells and whistles, the people don't come. But then if the people don't come, then you don't have the people to build the bells and whistles. So you kind of need to find a way to break this vicious cycle. I think part of it is also cultural. Like Rust people are, in my experience, generally averse at big libraries, big frameworks. People want to have the small Unix philosophy libraries. I'm gonna, take this crate that does one thing and combine it with this other crate that does one other thing, and make them all work together very nicely and build my stuff, which is very good approach to have in many situations, but it's pretty much a big lift every time you need to build something because you're basically building your own framework out of a bunch of components which are not necessarily designed to work nicely together. There's a pain point I keep hearing about, as I work with customers, clients, people in the ecosystem. What do we use? What we don't use? Does this work with this other thing? Obviously, async executors are a big pain point where people don't necessarily understand that they need to make a choice pretty early in the game and say, we're going to go with Tokyo, or we're going to go with this other thing. Because that choice then downstream affects a bunch of other choices they need to make. I'm going to use this HTTP library rather than this other HTTP library, or I'm going to use this crate instead of this other crate. Like Pavex is very explicit. We work on Tokyo. It's tested on Tokyo. It's built to work nicely with Tokyo. And I don't even try to get it to work elsewhere because I don't think the primitives that we have at the moment in the standard library are enough to make that A, easy for me, B, a nice experience for people using the tool. So we are opinionated in that regard. And there's many other opinions, throughout the framework as to what libraries need to be used. Like if you need to work with time, we are going to re-export a specific time library. Like we're not going to throw you at the wolves and say, go and do a code review of this 3-time library and pick the one that you like the most. To find out that then it's not supported by SQLX, or to find out that it's not supported by this other thing. So at a certain point, you need to pick your set of tools. And in Rust, this is mostly like a user problem. Every single user needs to build his own backend distribution. That's what I call it. In the same spirit of Linux, right? A Linux distribution is a bunch of tools that allegedly works well together. And you need to do this in Rust every time you're building something non-trivial. And if you're an experienced user, I wouldn't say it's easy, but it's easier. You've been around the block, you tried the various crates, you understand where the traps are, and so you can do this in a pretty agile fashion. If you're a new Rust user, by definition, don't have the tools to do some of the evaluations required to choose what you need to use. And so you end up going down a lot of dead ends, and that is painful. Or, finding yourself confronted with errors that you don't understand, simply because there's something wrong in the way stuff is supposed to work together, and it's at the level of Rust that you don't fully grasp at this point in time.
Yeah, I do like that idea because recently somebody came up to me and they were asking me, hey, I'm looking at Rust. I wanted to play around with it. Do you know which web framework I should be looking at? And I'm like, I don't know. I think this is what most people are using nowadays, but this is, so Actors Web has been around for a long time. A lot of people using it. You don't usually switch your web frameworks. It's really tough to say, but then there's Tokyo and they're kind of with Axum. And, I talked to the guy from Hyper. He's promoting something else. And there's some books on other frameworks. It's really difficult to say which one is the one to go to. You brought up this point about having all these things working cohesively together, and you kind of give them already like a choice, right? Like a ready-made pack. You want to go camping, here you go, here's your pack. You got your water, you got all your the stuff, the gear that you need, right? It may not be the best gear, but they work together well. It's a nice great package together. It reminds me of this conversation of with another Italian I talked to, this guy named Francesco Cesarini. I don't know if you've heard of this guy before, but so he's involved in the Erlang community, and he talked to me about for a long time. Erlang has been a telecom language. Not many people are talking about what telecoms are doing. They have a particular problem that they're trying to solve, and they don't really talk to each other so much. They don't really into open source so much in terms of kind of sharing their stuff. But Erlang did have at one point the fastest web server. I'm not sure which one it was. He made a point to talk about this. They had their own kind of like a LAMP stack kind of thing, but a different acronym. But they never really caught on, right? They were trying to push that it's the fastest ever. And then you brought up about Elixir. Well, Elixir has this Phoenix framework, and they came with all these different tools, and it exploded in terms of popularity and people kind of coming in relative to Erlang. And they looked at it, and you brought up another good point, which is what I think Elixir brings into like this whole Beam community, which is having the right tools, having all this stuff work together. You want to make web is still one of the most popular types of apps to make for different reasons. Having a great framework with stuff that works together, and you just kind of run a quick command, easy to configure, it just makes life easier and then even better, which is something that Rust has but needs to be better at. But your tool has that, which is plain English. This stuff is wrong. Here's some solutions. That I think is going to make this framework become really a big contender. Is it going to cause people to pull out their credit cards and force money to you? I don't know, but I hope it does, because
Nobody does until you try, right?
yeah, nobody knows. But I would say that you have a really great proposition. I'm excited to see what happens. I don't know how long it's going to take for something like this to show results. Do you have a rough idea about how long it's going to take for you to say this has got business or this has got value to it? Or, is it going to be several iterations of saying, okay, we tried this method, let's try another method to stay viable?
I think it's going to take a couple of years. That is my estimated timeline. Because it's a space that, is not super mature, but it's also, to an extent, it is mature. Like, obviously, yes, you're competing with other Rust frameworks, but you're also competing with other languages. So why should I go pay for a Rust framework when I can use Laravel for free? That is always like part of the equation. And then there's also the element of people don't take a new framework off the shelf and go build like a bank with it the day afterwards. Some people do. I think that's very dangerous. But generally speaking, like people, see some new tool, play around with it a little bit, get comfy with that new tool, and then eventually they're going to make a bet with something more serious. And so we need to go, I think, through that evaluation, trial and error, experimentation phase. That's going to take a while. That's fine. Like, I think if it works and like it gains the right level of traction, then it's on a path to be sustainable eventually. Like, it doesn't need to happen tomorrow morning, it doesn't need to happen, next month, it doesn't need to happen in 2 months. But the mechanism needs to be there so that if it becomes popular, it's a good thing. Because that is the funny thing about open source. When a project becomes popular, it's a bad thing for the maintainer. From the point of view of the amount of work that just like drops on you compared to what you get out of it. I mean, it feels good because you've done something and it's popular, people use it, but that effect kind of fades out, and then you're left with an issue tracker with 1,000 issues and working nights and weekends. That's where we don't want to go. Like, you want to be in the situation where popularity is a good thing because it means that you have more resources to pour into the project instead of like less resources per user. So we'll see. Like, as I said, it's an experiment in many different ways. It's an experiment on the technical level. It's an experiment on the social level. Like, stuff is free, stuff is not free. What does that mean? Why are you doing things the way you're doing them? So many different things in here might or might not work, and we might have to tweak technical stuff, the payment stuff. We might have to tweak a lot of stuff. But it's fun, right? A lot of people are like, this is not going to work. And my answer to that is, nobody's tried. So, let's try and fail, and then we reassess, rather than, start defeated. Okay, it's not going to work. Just, throw in the towel and go home. So I'm excited, and obviously, I've been working on this for a long time. I'm putting a lot of hours into this. I wouldn't do it if I wasn't convinced that there is something. You got to have a little bit of that irrational, I think we're going to make it type of thing. As we go into open beta, which is going to happen soonish, don't quote on me, estimates, blah, 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 but let's say a couple of months. I think there's a couple more things that need to land. And then I think the core is pretty stable. So we can start to just, let people self-enroll into the framework. As we go in open beta, the stuff hits the road. I think we're going to quickly see what's the reaction. And then based on that, we'll see where that goes.
Do you know, like, what's the price point that you're aiming to charge, or that's still something you're considering?
TBD, as many things, but the idea is, as I said, that it's free if you are a developer doing a couple of solo projects. It's going to be free for open source projects. So if you're doing something that's on GitHub and it's permissively licensed, use it. It's fine. Open source for open source. As long as nobody's making money, it's fine to use it for free. The price point for getting support obviously is going to be much higher. And that's going to be comparable to you requiring support with SLAs from any product. So it's not going to be for hobbyists. Let me put it this way. Like an hobbyist might pay 4, 5, 6 euros if they want to have GitHub level support, which is I open an issue and it gets troubleshooted eventually and it gets fixed. If you want some serious level of support, like you got some private repos to look at, you got some custom development to be done, you want to be able to ring somebody deep into the night, then we're talking a completely different price point. But that's because we're talking at companies. We're not talking in individuals. Like the idea is always that you want to charge people at a price point that they feel it's a steal. That is not zero, but they feel it's less than the value they're getting out of the tool. Obviously, nailing the price point is more of an art than a science. And so that might take some iterations. You might shoot too high, you might shoot too low. And so, undersell what you're currently doing. So I'm sure that is going to go through a bunch of experiments. But the idea is not to make this something that, if you are a solo dev, you got to check up £1,000 per month. That's not absolutely the point. The point is to charge people at the right price point for who they are. So individuals, indies, solo consultants, something very affordable. Big companies, something that scales with how much they're using the framework. So something that scales with the value they're getting out of the tool.
Okay, makes sense. I don't think I have any more questions. I think the video that you put out was quite good. But of course, digging into the documentation that you spent a lot of time on, that is also quite clear. But I think that once this becomes open, people start playing with it openly, we're going to get a lot more information. And once you reach that stable point, the 1.0, as you call it, it's going to be super clear, like kind of what's going on, and everybody will be checking it out, right? Is there anything that we didn't touch on that you wanted to say before we sign off?
No, I think that was a pretty good overview of like the technical and non-technical aspects of the project. As we mentioned before, obviously check the episode notes. Those are going to contain links to the videos that were mentioned, both from myself and others. And you can find the framework at pavex.dev. There you can sign up for the private beta if you're listening to this while it's still in private beta. If you're listening to this while it's in open beta, you can just start using it. And there you find the link to the documentation that Alan was mentioning, that you're free to browse. Hopefully it's quite clear. There's a quick start tutorial and a bunch of guides. I did my best to make it nice and to make it so that it's up to date. As always, it could be better, but if anything there is not clear, just give me a ring. I'm happy to have a second look.
Great job on the docs and having the video. Made everything really clear. The only thing that I wish the docs had, but that's really hard to do, is like seeing all of the code, because I was just trying to keep everything in my head, like, the structure and what's where, because I like to look at all the files and see how it relates, but you can't really do that so easily with.
That's technically something that I can do. Let me go into that for a second, because it's my pride and joy, is the way the docs are built. Let's talk about the tutorial. For example, the quick start tutorial. The quick start tutorial, behind the scenes, it uses Pavex new. So it generates a new Pavex project starting from the scaffold that you would use yourself to do a project. And then every code snippet is extracted from that project. Every time we're doing a modification, there is a commit. So you could actually, with a tiny bit of code that I haven't written, materialize the project at every step of the tutorial and have a one-click, basically gives you the state of the code base at the point of this code snippet. And that's how the stuff stays up to date, because we go through that process in CI. We make sure that stuff compiles at every step. Or if it fails, we make sure that it fails with the right error messages. The error messages as well that you see in the docs, they're not static, they're dynamic. Like, we generate those from the example projects to make sure that they stay fresh. And also to make sure that they're not, reducted. When you look something and wow, that looks so cool in the docs. Why does it look so shit in my terminal? Like, we want to actually show you the stuff as it would be if you were using the framework, because otherwise it's disorientating, right? You see two different things, you can kind of connect A to B. Spend a lot of time on that, probably too much time. But it comes from the experience of having like zeros production and not having that system. And then, you fix some stuff and then you forget to update another code block somewhere else. And then somebody comes back complaining like, yeah, you fixed that, but then, this is now stale. So I was like, I'm going to do something nuclear for this documentation, so I don't have to do that ever again. Makes writing the docs more complicated, but it makes maintaining the docs a lot easier.
It also makes the docs, like you said, much more real, right? It's always a famous, McDonald's thing. The picture looks great, you get it smushed, or not even close to looking for like the picture, right?
Yes, this is not what I ordered, type of thing.
Yeah, exactly. Yeah, great. Really thank you for that. And I think, all this time you spent, yak shaving, I think is paying off. I just hope that you don't get too distracted with all these things that you want to do, because it definitely makes it better. But, there's always a concern that, I think Carl, right? We started Tokyo because he wanted to do something else, and then he just got distracted and kept going with something else, right?
I mean, he got distracted into making Tokyo, right? I think the final outcome is pretty good.
Yeah, exactly. It's not a bad thing. It's just like, for something that does look very exciting, I don't know. Unless there's just something Tokyo-like that's going to come out of this, I don't know if I want you to get distracted. That's my concern.
I mean, I tried not to get distracted insofar as I tried to make things as not reusable as possible. You could have gone about building Pavex saying, I'm going to build a general purpose dependency injection engine that then is going to be used by Pavex. But then I'm going to make it so that other people can use it for doing that stuff. And that is possible, but then suddenly you're building Tokyo as a byproduct, right? You spend all your time making this beautiful, perfect to use, reusable engine, which takes a ton more effort than making something that just barely works for the type of stuff that you need to make inside Pavex. So I've tried to be disciplined, obviously, within reasons, one always gets carried away a little bit. But I've tried to optimize for speed of iteration on Pavex rather than reusability of the components underneath it as much as possible.
So it's good to hear, right? Maybe when things become more open, right? Maybe people will help to make those into more reusable pieces. Who knows?
It's possible. But, my primary drive is to get a good web framework, not to build very good reusable libraries. I think that is a secondary goal that can be reached at a later point in time. It helps me to keep everything together because then I can write hooks that allow me to do some stuff faster. I mean, the internals of the compiler are not necessarily the nicest code, but it's pragmatic code. It gets nicer if it needs to get nicer.
Well, again, thanks for coming on and talking more about Pavex. I've been asking you for a long time to start talking about it and hear some more. And so I'm glad you finally came on to tell everybody what's going on with it.
Absolutely. And thank you for having me.